right, so we got some more examples of collisions with other stuff happening. I call them collisions plus, but really this is just the multi-part problems. This was example one, right? We're gonna do the next three examples just to give you some more, um, just like ideas of what we can look at here. All right, so we got a block that explodes into two pieces, and it then slides on a flat surface. So we're talking like a 1 kilogram and a 2 kilogram block, and they're going to explode into separate directions. All right, and then they're going to slide some distance because of the kinetic friction, right? So the first thing that happens, right, part one, this is an explosion. And as we know, the way you solve an explosion is momentum conservation, P initial equals P final, and kinetic energy initial, right, plus the kinetic energy added equals KE final. Okay, so let's go ahead and do that, right? I think we have enough information to do it. So I've got 0, the initial momentum, equals 1, and I'll call that VA, right? So this is my block A and block B, plus 2 VB. Cool. Which means that really I can just solve this. VA equals negative 2 VB. All right. I then am going to look at my kinetic energy equation. I've got 0 kinetic energy initial plus 30 equals 1/2 times 1 times VA squared plus 1/2 times 2 times VB squared. So this is 30 equals 1/2, and VA we know is negative 2 VB squared plus VB squared. This comes out to be 2 VB squared plus VB squared equals 30. VB squared equals 10, which means that VB equals 3.1. I think that's 3.13. Is that how the math works out? 3.16. Sorry, just for a second. We can plug that right back into here, which means that VA is going to equal negative, right, 6.26. All right, so now they've done that. But the second thing that happens is they both slide, and we actually want to treat them as separate sliding objects. So this is really going to be like parts 2A and 2B, right? So part 2A is the A block sliding. I've got an initial, right, it's going this way. Right, that's my velocity, which means my friction's this way. And I guess we'll make left positive or left negative. Just to keep everything consistent. Although this we could have reset it for this problem, but that's positive. So V initial negative 6.226. That's not 6.26. That's 6.32. I did bad math. Right? V final is 0 because we want to see how far apart they end up. Okay? And then we have acceleration. The way we find acceleration, right, is F net horizontal equals force of friction, which is normal force times UK. So this is 1 times A equals 1 times 9.8 times 0.25. A is going to equal 2.45. V initial, V final A, I've got change in X equals V initial times time plus 1/2 AT squared. And I should not do it that way. So even though I have that, that's a really bad way of doing it. I want to do V final squared equals V initial squared plus 2A change in X. 0 equals negative 6.32 squared plus 2 times 2.45 times change in X. And we're going to get change in X from this is equal to negative 8.15. The fact that it's negative is good because it was going left, and my left was negative. So then for part 3, or part 2B, I guess, same basic idea. I'm going to skip. V initial is 3.16. V final is 0. A is going to be, and we can actually do this, because the masses cancel out in this, it's going to be the same thing, only negative, because it's going the other way. Negative 2.45, which means that change in x, and we do it all out, is going to be, with the same equation, is going to be 2.04 meters. That means one of them went 8.15 meters left, one of them went 2.4 meters right, so we're talking 8.15 left, 2.04 right. This is where A is. This is where B is. Could have drawn that better. Right, which means that the total answer, my answer is 10.19 meters. That's how far apart they end up. Okay. All right. Piece of clay launched into the air. Okay, so we got, it's going to swing up, it's going to fly up, it's going to hit a block that's hanging from a string, and then this is going to slide up a little bit. Okay, it's going to end up being like up here. And what I want to know is, I want to know what that height is. Okay, so first we've got part 1 is 2D kinematics. We've got part 2 is a collision. Right, that's mean momentum. And we've got part 3 is going to be the swing. And this is a object that's changing height, but not in a straight line. That means energy conservation. So let's start from the front here. So I've got V initial x and V initial y, which I can find, right, by doing trig. This is V initial x, V initial y. Five. Three. Okay. So 3. AX equals 0. AY equals negative 9.8. Equals 2.5. So let's go back to and we have it's at its max height, which means V final y equals 0. Now, what I want to know is, I want to know what the x velocity is. I want to know what the x velocity is when it hits. And since acceleration of x is 0, V final x equals 4.33. So that's going to be my initial velocity for the collision. So V initial 4.33. So I have 0.2 times 4.33 plus 0.5 times 0 is equal to V final times, and this is the 0.2 plus 0.5 because they stick together. Solve that out, I get V final is 1.24. Okay. I get to the swing. Right, this is kinetic energy initial plus potential energy of gravity initial plus non-conservative work equals kinetic energy final plus potential energy of gravity final. Okay. I'm going to make the initial height 0. There's no air resistance or friction, so that's work non-conservative 0. And I want the maximum height, so kinetic energy final is 0. So just 1/2 times 0.7 times 1.24 squared equals 0.7 times 9.8 times h, which is what we're trying to find. And when we solve that out, we get a height of 0.078 meters. So it rises 7.8 centimeters in that swing. Okay. All right, last one here. Okay, we got the ramp again. This time it's not frictionless. but I told you about the work here. Ramp again. So we've got block A. At the bottom, it's going to hit B. And they're going to both fly off this ramp. But they're going to land different places. B is going to land somewhere out here. And A is going to land, dotted line is A. A is going to land here. Now I know how far A goes. It's 1.3 meters. Okay. So, first thing that happens, I got a curved slide. Right? This is E conservation. Okay. Then I have part 2. It's my collision. Okay. And then I've got part 3 A and part 3 B. And I'm going to do it differently, right? Because A is going to do kinematics and B is also going to do kinematics. They're both going to be projectiles. So let's do the curve. Let's go through this. So you got the curved slide. Okay. The curved slide. And I'm actually trying to put some things between this, okay, so we know what part I'm looking on here. Okay. My curved slide. I've got kinetic energy initial plus potential energy of gravity initial plus non-conservative work equals KE final plus potential energy of gravity final. 0 plus 3. Oh, nope, times 1. Mass is 1. It's the height that's 3. 1 times 9.8 times 3 minus 10. That's my non-conservative work equals 1/2 mv. Oops, I know what v is. Sorry, I know what m is. So 1/2 times 1 times v final squared, and I should have said this earlier, but this is 0 and that's 0, right? The height at the end is 0 plus 0. If I work this out, v final is going to be 6.23 meters per second. That goes into my collision here. So I've got, oops, extra random mark there. So I've got 1 times 6.23 plus 0.5 times 0 equals 1 VA plus 0.5 VB. Two variables I don't know. All right, that's fine. You get stuck with it, you realize you can't do it. Let's move on. What about part 3 and part A, or part 3A and part 3B? So this is 2D kinematics. So V initial X unknown, V initial Y 0. They're coming off horizontally. AX 0, AY negative 9.8. Change in Y negative 1. And change in X for A is given. It's 1.3. We do the same for part B, right? V initial X also unknown. V initial Y still 0. AY equals negative 9.8. And change in Y equals negative 1. AX equals 0. But here's the problem. Change in Y is also unknown. So the fact that I have one more piece of information in part 3A, which means I should probably do it here. So to find time, I want to use Y. I've got 3 variables in Y. I can find time. We're going to use change in Y equals V initial Y times time plus 1/2 AY t squared. Negative 1 equals 0 minus 4.9 t squared. T is going to end up being, from this, 0.451 seconds. I got T. I can go back and find V initial X, then is going to be equal to, well, let me start with the equation. Right, I can go back, I can do change in X equals V initial X times time plus 1/2 AX t squared. Right, this whole thing is 0, so 1.3 equals 0.451 V initial X. V initial X is then going to be 2.88. that's 2.88. That is then the V final here. So now I've got 6.23 equals 2.88 plus 0.5 VB. And VB is equal to 6.7, which becomes the initial velocity over here. So now I've got V initial x, right? It's no longer a question mark. This is now 6.7. My time, it turns out my time is going to be the same. It's going to be 0.451 seconds, which means my change in x is going to be 3.02 meters. And so B flies 3.02 meters across it. Okay? Sum it up, break it down into parts, figure out what's going to solve them, and then solve what parts you can. You're not always going to be able to do it in order, but solve whatever parts you can and do the best you can.